Hello everyone. Very quickly in this class, we are going to see how we can solve this problem on indices. We have that 2 to the power of 2x plus 8 minus 32 in brackets 2 to the power of x plus 1 all equal to 0. Now, solving this problem, we need to have in mind the law of indices. We need to always have in mind and respect the law of indices. Now, we can recall that anytime we have the same base and we're multiplying, we'll add the powers. Anytime we have the same base in indices and we are multiplying, we add the index. So we are going to take what we have here back to what it was for the sake of convenience. We have 2 to the power of 2x plus 8. Now remember that what the law says, anytime we have, for us to add the index, we must have the same base. So for them to have added 2x plus 8, there must have been 2 to the power of 2x plus 2 to the power of 8. Let's take for instance what I mean. We have 2 to the power of 2x times 2 to the power of 8. There must have been something like this. For them to get to this, there must have been something like this, which 2 and 2 multiply, you have 2 to the power of 2x plus 8. Because the best way to add 2x and 8 is just this way, because they are not like terms. So we are going to take this back to what it was by having 2 to the power of 2x times 2 to the power of 8 minus 32 in brackets 2 to the power of x plus 1 equal to 0. So if you take a close look at this 2 to the power of 2x we have here, you will see that we can still break it down further more. So if we break what we have here down, x plus x will give us 2x, and so therefore 2 to the power 2 to the power of x times 2 to the power of x will give us 2 to the power of 2x, because x plus x is 2s. So if I multiply 2 to the power of x and 2 to the power of x, I will definitely get what I have here, right? So it means we have 2 to the power of x twice. This is what it means. So I'm going to replace what I have here by 2 to the power of x twice times 2 to the power of 8 minus 32 into 2 to the power of x plus 1 equal to 0. So I have simplified this thing to a reasonable extent. Now let 2 to the power of x be equal to p. Let 2 to the power of x be equal to p. So anywhere I see 2 to the power of x, I will substitute p for 2 to the power of x. Now in this case, I have p squared times 2 to the power of 8 minus 32 p plus 1 equal to 0. Right? So now I'm going to take out the brackets. I have p squared times 2 to the power of 8 minus 32p plus 1 is equal to 0. So if I multiply what I have here, I have 256p squared minus 32p plus 1 is equal to 0. So if you take a close look at this, you will understand that what we have here is a quadratic equation. What we have here is a quadratic equation. So we are going to solve this problem quadratically. Now we are going to multiply, since p squared have a coefficient, right? Since we have 256p squared, we are going to use this 256 to multiply our constant, which is 1. So when 256 multiplied by 1, we'll still have 256. Now we're going to look for two numbers that when we multiply those two numbers, we'll have 256, and when we add them, we'll have negative 32. And those two numbers are negative 16 and negative 16. Now remember, we are going to substitute, we are going to take out this negative 32, which is the middle term, then replace it with this 16 and negative 16 and negative 16. So bringing down what we have 256p squared. Now we're going to take this out and replace it with these two numbers, then putting the coefficient of p, adding them to both sides. So we'll have negative 16p minus 16p plus 1, and bringing down the constant, is equal to 0. We are using the factorization method in this case. So I can factor out something, 256 in 16p. I can factor out 16p because I have p here and I have p here. So I have 16p. In this case, I have 16p minus 1. Now remember, I said you will factor in a way that when you multiply back what you have, you will definitely get what you have initially. 16p times 16p will give me 256p squared, and 16p into negative 1 will give me negative 16p. So in this case, I can factor negative 1, and in this case I have 16p minus 1, right? So I'm taking this factor and this factor, then any one of the bracket, because they are the same. So I have 16p minus 1 is equal to 0, or 16p minus 1 is equal to 0. So 1 crosses the equal to sign. I have 16p is equal to 1. Now I can divide both sides by 16, right? To cancel out, if I divide both sides by 16, so p will be equal to 1 over 16. And that is the same case here, because when 1 goes to the other side, I have p to be equal to 1 over 16. Now we'll have, for the solution of this quadratic equation, p is equal to 1 over 16 twice. Now recall that p is equal to 2 to the power of x. So if p is equal to 2 to the power of x, 2 to the power of x will be equal to 1 over 16. And the only way to cancel out this x, the only way to look for the value of x in this case, is to reduce 16 to be equal to the base, which is 2, so that we can cancel out. And how do I do that? I have 2 to the power of x is equal to 1. I will raise the index of 2 to the power of 4 to get 16. So I have 2 to the power of 4, right? So what I have here, 2 to the power. Now getting out this fraction, which is 1, I'm going to replace this with negative sign attached to the index, which is 4. So I have 2 to the power of minus 4, right? So when we cancel out 2 and 2, x will be equal to negative 4, which is the correct answer to this problem. Bear with me, the light just went off. So this is the correct answer to this question, correct answer to this problem. X is equal to negative 4. Thanks for watching. Hope to see you in our next class. But make sure you like, comment, and subscribe to the channel. See you in our next class. Bye.